In this module, we're going to look at a really useful cognitive ability, which is the ability to solve problems. And before I start delving into what that entails, I'm first going to lay out how problem solving is a specific type of cognitive activity. It's a form of thinking, but it's also different from some other related forms of thinking. So when we think about thought and reason, thinking itself can be defined as a process of mentally representing some aspect of the world and transforming these into new goal directed representations. So, the key thing here is really for me in the second part, the transforming it into new goal directed representations. Thought is not just passively regurgitating what you already know, so activating representations that you already have, but specifically transforming these into new kinds of ways of thinking about the world. Within thinking, there's a distinction between reasoning and problem solving. So, reasoning specifically deals with cognitive processes that we use to make inferences from our knowledge and then draw some sort of conclusion. Whereas problem solving is very specific to a situation where we're stuck. We have a set of cognitive processes when we get stuck, and we use those processes to try to overcome obstacles so that we can reach a goal, which at the broadest level, that goal is to no longer be stuck. Problem solving is interesting in the sense that we have to transform the way in which we're looking at something in order to actually be able to overcome that being stuck in that particular problem state. So Einstein said about this, we can't solve problems by using the same kind of thinking we use to create them. And that is very much the case. We have to try to look at the situation that creates the problem differently so that we can then approach it with a new representation, and then that new representation hopefully contains the correct solution. When we look at problems, uh, it is a purposeful state, right? We want to solve a problem. It's a goal directed state where we're well aware that there is a problem and we try to now work through it so that we can get rid of it. Because of this, it involves controlled cognitive processes rather than automatic processes. And what's interesting about problems too is that a problem state only exists until we have solved it. Once we have the relevant knowledge and we know how to use it, problem is solved and it actually ceases to exist. When we look at the structure of problems, problems can be broken down in three different stages. The first state is the current state where we realize that there's an issue, we're stuck. Then there's the goal state, is the state that we want to get to, and it's the state where we have solved the problem. And the in between state is the most interesting state. It's called the operational state, and it's where we think the building blocks are present to solve the problem, but we have to figure out exactly how to use the right building blocks, so the set of mental operations that we need in order to get from the initial state to the goal state in which the problem is solved. So problems consist of those three states. There's some distinctions too in how problems differ from one another. And one big distinction is whether a problem is knowledge rich or knowledge lean. And this is a really simple dimension. Some problems require a lot of prior knowledge in order to be able to actually be able to solve it. So anything that relates to science, physics, particles, the Higgs boson particle, any question like that, if we want to understand anything at that level, obviously these kinds of problems require a lot of prior knowledge. So those are knowledge-rich problems. And some research on expertise specifically looks at how experts are able to solve problems within their domains that are all knowledge-rich. On the other hand, there are also many problems that are more everyday, that don't require as much prior knowledge, but nonetheless involve states where we are stuck and we would like to not be stuck. So, for example, when the zipper on your backpack gets stuck, now there's a problem state because you would like it to not be stuck. You have ways of trying to get it unstuck, and these ways don't necessarily require a ton of knowledge. So, that would be an example of a more knowledge lean problem. And there's a lot of traditional research that actually looks at how people approach those more knowledge lean problems. This is a continuum. So, for example, imagine that your router is not working A first fairly knowledge lean solution to that may be to unplug the router and then to plug it back in. Doesn't require a ton of knowledge about how routers works, but it's typically the first thing that's being suggested. That would be a knowledge lean solution if that ends up working out. However, it's also possible for a router not to work because there's something wrong with the way the IP address is being assigned or something like that. And in order to be able to solve that, this would now have become a much more knowledge rich problem. So, this is just to show you that these are not sort of absolute distinctions. Problems fall somewhere along that dimension of how much knowledge is required in order to solve them. So that's the first continuing. Now, another distinction along the spectrum of different types of problems is whether they are well-defined problems or ill-defined problems. And a well-defined problem is a problem where everything is basically specified. There's an initial state, there's a range of possible moves you can make or strategies you can employ, and then there's some sort of goal that you're working to. All of this is spelled out. There's an optimal strategy, there's one right answer. If you contemplate all the possible moves, you should be able to come to the one solution. Examples of this are, for example, mazes, right, where there's only one particular path out of the maze. Chess, where there's a set of rules that govern what that game is. It's very well defined. You can't make any moves outside of those rules. Anything that's studied in a lab oftentimes involves some sort of well-defined sequence of steps that you have to take to solve a problem. And then I'll post a video that's called the Monty Hall problem that is an example as well of a problem where it's actually very well defined. And the Monty Hall problem looks like this. Watch the video I'm posting, but it's basically where there are 3 doors, 2 of them have goats behind them and one has a car. A person picks a door in the first step. After they pick their door, the game show host then takes one of the other 2 doors and reveals a door that has a goat behind them. And then the contestant is asked, do you want to switch to the other door that's now left? And the question is whether you should do this or not. The answer is yes, you should, but you will see why that is. Key thing here is that this is a very well-defined problem. Each of those doors have certain probabilities. Switching or not switching has a certain probability, and so forth. Opposite to well-defined problems are ill-defined problems, where sometimes the goals are not fully understood or specified. It's not entirely clear what we should be doing to get from the initial state of being stuck to the goal state of being unstuck. And I'm posting a video too that shows an example of that, where researchers in Sweden were interested in why it was that people weren't wearing bike helmets. So the first question there is, why is it that people are not actually doing this? And that first question actually helps with defining the problem itself. Now, once the reason for that gets identified, then you have a problem and you could try to think, oh, how can we design a bike helmet so that whatever the reason is that's stopping people is now mitigated and now people may actually start wearing this bike helmet. So watch that video because it's quite interesting. Insight problems where people all of a sudden have this realization of how to solve something, they happen a lot in ill-defined problems as well. So sometimes, you're stuck on something, you don't exactly know why. You take a shower, you depart from the problem for a while, and all of a sudden you have this moment of, aha, I got this now, and the solution comes to you in this ill-defined state.